Now, the second weakest intermolecular force category is going to be Hydra Bonding. Now, Hydra Bonding is kind of a weird thing. So, Hydrogen bonding we see most readily with water. So if we have two water molecules, H2O, these will dissociate to give us H3O plus AQ plus OH minus AQ. And this is the auto-dissociation of water. Now, we can get this with a lot of other things. We can get these with alcohols. So alcohols are any carbon-containing compound with this OH group. And we can get these with amines, a carbon-containing group within an H group. The point here is that we do actually see ions. Now, we would traditionally say water, alcohols, and amines are all organic compounds that participate purely in covalent bonding. So I told you in the ionic videos, some things are said to be ionic that really aren't ionic. Some things are said to be covalent that aren't truly covalent. This represents the extreme end of a polar covalent bond. It is so polar, it actually forms ions. And so we do have a degree of ionic bonding when it comes to water, ROHs, and RNHs. But the thing is, we have an equilibrium error. So this is a tiny amount. Here we only have 10 to the negative 7 molar of these two ions. So we're going to call this classification of intermolecular forces hydrogen bonding. And we call it hydrogen bonding because we have a hydrogen jumping ship to a different atom. So in the case of the alcohols, we have two OH groups. One hydrogen is going to go to the other atom molecule, give us a plus, give us a minus. So it's going to end up giving us some ionic bonds within this really polar covalent mixture. Now, this is going to represent the second strongest intermolecular force interaction we see. So hydrogen bonding is really up there. It's the extreme for the covalent compounds. And it is super strong. If you look at something like water, water doesn't boil to 100 degrees C, whereas we compare it to an alcohol of comparable weight. Something like methanol, that's 40 to 50 degrees C lower. It's these trace ions here that are giving rise to these strong intermolecular forces.